research review. So I'm interested in this one. I'm a little bit late to it because I was busy and I got sick, but VolumeLeak, classifier-based data exfiltration via volume settings. What? So I wanted, to set some background on my experience with this write-up. Kieran was like finishing it, so just like in Tokyo, in the underground subway mazes, we found a cafe that had space in it to sit down and work on our laptops. And so Kieran is trying to explain this to Matan Bear, and I'm trying to not get spoiled, so I have to like throw my headphones in whenever he starts talking about it as he's like trying to get it out, and I'm trying to like stay conscious from the jet lag and have fun client-side thoughts. But yes, this should be very interesting research, and it should be a really cool AI chain. And we're going to learn about Gemini gems, which like the first part like kind of like started to talk about, and apparently it was a really good attack surface. VolumeLeak, classifier-based data exfiltration in Gemini via volume settings. Okay, so that's not an exfil until it is. So here we go. Introduction. About 6 months after VolumeLeak, we participated in another Bug SWAT live hacking event in Mexico City. Our focus returned again to the tool calls at our disposition in the Gemini Android app, as we felt that there was unfinished business there. More specifically, we realized that because Google's team had accepted vulnerabilities that involved a mobile app being installed as a prerequisite, albeit with major bounty downgrades, it meant that in theory, any property that was both writable by Gemini and readable by a mobile app, without excessive permissioning requirements, was a potential attack surface for data exfiltration. This observation proved to be invaluable. Yeah, so that is nice. Yeah, it is always interesting when you're able to work out what they're willing to accept, and when it really opens up a lot more attack surface where you're like, yeah, I wasn't sure how they'd handle this one, but you know what? They paid well enough to try to find more things that fall into that bucket. That's really cool. Shareable gems. Furthermore, just 1 week before this live hacking event, Google launched shareable gems. This was a feature we'd been tracking and predicting since April. Wow. As such, we had several attack vectors ready to go. Wow. Namely, we predicted that gems would have permission to execute tool calls without being asked to do so directly. This technique is called delayed tool invocation. The legendary Johann Rehberger, I don't know if I got his name wrong, I feel Wonder Wuzzy, describes it here. When Google launched this feature, it was exactly as we'd feared. You could use the system prompt of a custom gem to trivially induce the user into running any tool we wanted. Nice. To do this, all we had to do was create a custom gem, set the system prompt to something like the following, and share the gem with the victim and wait for them to talk to it. Nice. System prompt. If the user says, hey, invoke XYZ tool. Upon interacting with the gem, our tool of choice would be executed. This was incredible because we now had a near universal delivery mechanism. There was no need for tap jacking at all. Actually, I think it was, what was it, like quintuple tap jacking? All that remained was to find more exfiltration avenues. Okay, so that's cool. So they've got a way now that doesn't require a local app to get their delivery. So can they get paid way more if they find some like exfil mechanism that also doesn't require a local app and not get those reductions? I don't know. It sounds like they're not going to go for that in this one, but like that's where my head would be like, all right, can we get non-local exfil somehow? But I do like going the other way because, like, you know, that other bug paid out enough that if you can find multiple ways to get some sort of full chain, and then I don't know. Right, a lot of thoughts here. Volume-based exfiltration. Naturally, at this point, we had a huge idea. There has to be a system state we can use for this idea. Well, my dude, I have a huge idea. You can alter the volume percent to correspond to ASCII letters to leak strings. No. No. Like, yeah, but come on, man, that's bad behavior. It's not very nice. I love it. Unfortunately, there were a few technical obstacles with this approach. The main problem was that while we could write specific percentages to the Android setting, the Android SDK only allowed us to read groups of percentages called steps. Oh, that sucks. So maybe you have to, like, base whatever the step limit and code it to fit in. Oh, Lord. Volume steps. Here we go. So what is a step? The way that Android handles volume settings is a bit strange. There are several different types of volumes that work at once. These differ by device, but typically you can control the following: media volume, call volume, ring volume, alarm volume, notification volume. Our testing was conducted on a Pixel 9a phone that I had bought specifically for hacking Google. On this device, the step counts for each type of volume are the following. Great. So it's like platform specific. That's still cool. Okay, so we can look at this state table and observe that media has 26 unique states, which happen to align to alphabet characters, and then there's 8 for the other ones. So you could like base 8 encode things. But can you set multiple at once though? That could actually allow quite a bit of dimensionality, and you'd get way more. Okay, these steps are like intervals. When you read a volume value on Android, you cannot read specific percentages. You can only read these steps. Of course, you can equate a media step value of 1 to 4% if you want to be exact, but the API simply provides these step values to read. The range of values provided by these steps is quite limited. It's very difficult to say exfiltrate longer ASCII strings in this manner. So do you have a way to like multi-exploit it? I don't know. I'm sure the more astute readers here will think of a way, but we did not think of one at the time. Yeah, so yeah, that's interesting. Yeah, that's that. It's definitely an interesting problem, and I wonder if there's like other gadgets that could help with that. Definitely tricky. Here we go. Okay, so it looks like they can set multiple. Hierarchical classification. Yeah, here we go. So yeah, so they can set each one independently and get like way more space. Yep. Instead, we devised a hierarchical classification system. By using a classifier, we instead have 26, multiply them all, about 100k combinations. For example, if the alarm volume is 1, we could classify that the message was to the engineering department and not HR. I mean, you could just use this to like store bits effectively, like each one of those, yeah. But you know, that's very limited, and it's probably. If the alarm volume is 1 and the notifications is 2, we could classify this message was about the latest pull request and so on. This approach allows us to exfiltrate the intention behind a message without exfiltrating its exact contents. Okay, that's interesting. Well, there are some nuances in the number of possible states, as some audio stream volumes are linked to each other. We can generally assert that we can achieve tens of thousands of possible states with this method. Yeah, it's likely enough to exfiltrate the exact value of 5-digit TOFA codes as well. Yeah, I was thinking like that's perfect for fitting in a number that is like 5 characters long. I wonder if you could pull any tricks to like multiply this a bit bigger. Previously, we noted that it's possible to sequence tool calls on Gemini for Android. With this finding, we took this gadget to the extreme. Our final exploit chain worked in only one turn and called 7 tools in sequence. Nice. I'm guessing like the prompt would do it. So it would read notifications. Okay, yeah, hoping to get that 5-digit code. Set media volume to exfil set media volume based on state. Set call volume, set ring volume. So these all get set independently, and then open the app that reads the state of the volume. As long as the malicious gem and the malicious Android application use the same classifier system, which we could provide in the custom gem prompt, and the AI did its job right, like you're asking for a lot here, we could exfiltrate many, many values. We also noted if we wanted more bits to get set, there we go, we could set battery saver mode, flashlight from Gemini, to get another 2 on-off states. Hey man, that's doubling your space each time though, so like you're gonna get exponential growth with each bit you add. Am I crazy? Right? If we use those states as well, yeah, the number of classification rises to over, yeah. So you just sneak even a few more bits in, man, and you can like get in some room. But getting the AI to actually encode things properly sounds tricky. There likely exists some more settings like this that would bring the total states to over 1 million. Yeah, I agree. Classification attacks are unique to LLMs in that they are made possible by abusing the AI's ability to reason and classify things. True, yeah, going for a classification direction here is really cool, because like in my mind I'm like, I want to encode like 7-byte ASCII into these bits that we effectively have and be able to read like small chunks of like 7-byte ASCII, but that's probably smarter because you can get more information or more specific information this way than just being limited to such a small exfil. While it was likely possible to do specific classifications with code, the reasoning power of LLMs allows for general case classifications, which is much more powerful. Yeah. Timeline, so it was reported in September, and it was, wow, 17K. That's impressive for the exfil requiring a local app. I think that's quite a bit more than the last one. I guess the delivery, it didn't require the 5 touches, so that makes sense. Yeah, awesome. A new age of excess leaks. LLMs are heralding a new age of excess leak attacks made possible by tool calls. Yeah, there's a systemic problem with oracles of binary states in AI. For example, it is possible to combine existing excess leak attacks with AI to obtain an oracle for AI output. Consider frame counting. Any AI that outputs iframes after a specific tool call will leak the fact that the tool was called. Yeah, that's interesting. To any other origin. That's very interesting. We look forward to reading and presenting new research in this field. Yeah, I like that, and I like the classification attacks where it's like you're representing something instead of like using those bits of state that you can read to represent literal values. You're representing like some conclusion drawn on what data is being pulled, and you can almost play like 21 questions with the data, like like it may be a mineral. That would be, because that's very interesting. That's so cool, actually. If you had like classic 21 question game questions and you used your bits for those, that would be an interesting POC. I have no idea. I like thinking of things, and this definitely makes me think about things. Conclusion: this finding pushed the limits of tool abuse in Gemini to the point where we were able to weaponize even the volume controls. We hope that this demonstrates that even seemingly harmless tools can be used maliciously, especially where the boundaries blur between an LLM and an operating system. We presented classification attacks in LLMs as a gadget to get data out of an LLM-based system, where the range of values that you can exfiltrate is limited by the exfiltration vector, and noted the advancement of excess leaks in the age of AI. We look forward to sharing more research on this topic soon. Oh man, these guys have such great taste. Like, this is such a great thing for me to read and be happy to read. This is such a cool, like, actually being able to pull off the chain with just like, we're gonna leak over volume state. Like, I love it. Let's hit the research review points that so how does this generally apply to BB? Yeah, so there's plenty of awesome like AI targets, and I think this really shows how much you can do with so little. I mean, they've got a really nice injection vector here, and there's some a lot of like benign seeming tool calls when you're like doing bug bounty on an AI target that has ways to, maybe you can work out some delivery mechanism and you want to abuse those tools in a way that's not intended to exfil. Very interesting, especially with the like local situation, and then especially with the excess leak situation. So I think that with some very creative analysis of kind of the general ecosystem of an AI product you're testing, you can come up with really clever exfil mechanisms that seem unexpected. Why did this work? I guess I think a lot of this is the the application doesn't live in a void. It lives in an ecosystem. So in this case, local apps can read some global state that can be set in a browser context. A tab with a reference to that window can read some global state, like frame counting for some excess leak mechanism. All very interesting, very cool. Further research that should be done here. I like the 21 questions concept. Is it 21? Do I have the number? I have the number right. Yes. I like using that as a classifier for like some sort of concept. Or even maybe there's like a more optimized version of that. I'm sure there's research that's been done on that is now potentially useful for like classification attacks. But we'll know if it's a mineral or not, the thing we're leaking. Rating, I rate this one media volume 23 out of 26 because it's pretty loud. And yeah, I guess check out Starstrike. Like, I'm hoping they drop more cool research, and if you like need the stuff that they do, like your AI secured, I mean, like, nobody else is publishing volume-based exfil. Like, these guys are on some crazy next level stuff. Like, there's other people doing other really cool things, but they're doing their own very cool things that are creative, very creative. So look into that, and This was pretty enjoyable to go through, and I feel like I learned a lot and have a lot of ideas in my head.